Whenever we talk about graphing a quadratic in standard form, we're talking about our standard form right here of y equals ax squared plus bx plus c. Now a, b, and c, those coefficients are very important for what way we're going to solve. So first off, we always start with the line of symmetry here. And the line of symmetry is going to be x equals negative b over 2a. So when we plug in or substitute in the negative b value, the negative coefficient on the x, over 2 times the coefficient of a, it's going to give us the value that is that line of symmetry that the parabola reflects on. What's important about that is on the line of symmetry is the vertex. So we are first going to figure out the x value and then figure out the y value from that. So from the line of symmetry we get our vertex, which is negative b over 2a, or the same thing, and I'm going to write y of negative b over 2a. Now, a different notation there, but what that does is I'm going to substitute the x value into the equation. So whatever I get here, I'm going to substitute back into the original equation, and it's going to give me my y value, which is telling me where my vertex is. So that's going to help me, because really the three things we have to know whenever we graph a parabola is we need to know where the vertex is, the direction that it opens, and how wide it is. And this will get us started with the vertex. Other things that will help us is if I let x equal 0 in this original equation, then it gives me the y-intercept, which also gives me that if I make the x is 0, that y-intercept is c. It's that coefficient, or it's that constant at the end. And we'll see that as we work through. Now, other details that we have, if a is greater than 0, so if this is positive, then the parabola opens up. If a is less than 0, then the parabola opens down. And then the same rule that applies to the width will also apply here. If it's greater than 1, it's a more narrow graph. And if it's between 0 and 1, it's be a wider graph. We're not going to worry too much about that today. We're going to focus on the vertex and finding the points. So let's look at our first few here. I have negative x squared plus 4x minus 2. That's a, b, and c. So our line of symmetry is x equals negative b over 2a. So that's negative 4 over 2 times negative 1. Now, negative divided by a negative is going to give me a positive. 4 divided by 2 is going to give me a positive 2. So I'm going to put that into this original equation, negative 2 squared plus 4 times 2 minus 2. Now be careful with your order of operations. 2 squared is 4, so we got negative 4. 4 times 2 is 8, and then our negative 2. Negative 4, 8, and negative 2, this is negative 6. With an 8, that gives me a positive 2. So my vertex is 2, going to be 2, 2. So I'm just going to draw my axis here, x and y axis. 2, 2 is my vertex. Okay, it's a negative, so I know it's opening down, but what I can do is if I let x equal 0 in this equation, I'm left with is negative 2, and when x equals 0, it gives me the y-intercept, so that's the coordinate here at 0, negative 2. So I know what 1/2 of the parabola looks like. Now this is a line of symmetry though, and so the fact that I went 2 units away on this side is I'm going to go 2 units away on this side. At 4, negative 2 is my other point. It gives me 3 points, and I can draw my parabola. Okay, next one, we're going to go x equals negative b over 2a. So that's going to be negative 8 over 2 times negative 2. 2 negatives there, so it's going to be a positive. 8 over 4 is 2. So back to our original equation, negative 2 times 2 squared plus 8 times 2 plus 9. We have negative 2 times 4 plus 16 plus 9. Looks like we have a negative 8 plus 16 plus 9. That's going to come out to be 17. So our vertex is 2, 17. Now I'm not going to plot this point on the graph counting them out, but I'm just going to approximate, see what I can look at. So 2, 17. So let's say it puts it about right here, if we were approximating 2, 17. Now, it does open down. Let x equal 0. I'm left with 9. So 9, right here at 0, 9 is one of my points. That's my y-intercept. So that's half the graph. Now, off of my line of symmetry, I went 2 units over, so I go 2 units to the other side. So that's going to be 4, 9 as my other coordinate. And there's my parabola. Next, we have y equals x squared minus 4x plus 1. X equals negative b over 2a. So that's negative negative 4 over 2 times a 1. If it's just x squared, it's a 1. So positive 4 on top, 2 on the bottom, so it's a 2. We substitute that into our equation. We have 2 squared minus 4 times 2 plus 1. That is 4 minus 8 plus 1. Looks like we get a negative 3. So now we draw our x and y axis. Our vertex is 2, negative 3. Puts us at that point. Now, it's a let x be 0. We come out with a 1. It's just the c value in the end. That's our y-intercept. We are 2 units away from the axis of symmetry, so we go 2 to the other side, and that's 4, 1 is our coordinate. And then that gives us our 3 points to draw our parabola. Okay, we go to the back side. Some more. First off, we're going to start with x equals negative b over 2a. So that's negative negative 8 over 2 times negative 2. There's 3 negatives here, so it's going to end up being a negative 8 over 4, which is negative 2. We substitute in negative 2 times a negative 2 squared minus 8 times negative 2 minus 3. Order of operations, we're going to do the exponents first, so that becomes a 4. Minus, that would be plus 16, negative 8, and negative 2, minus 3. And so negative 8 plus 16 minus 3 comes out to be 5. So vertex is negative 2, 5. So we'll draw that. Negative 2 gives me an axis of symmetry there, and then we're going to go up 2, 3, 4, 5. It opens down. It's more narrow because of the 2, but really we can use that 3 at x equals 0. 3 is our y-intercept, which is right here at 0, negative 3. We had 2, negative 5. Now from here, that was negative 2, positive 5. Now from here I'm going to reflect it over, and that goes over to the point of negative 4, negative 5, negative 4, negative 3. And we have our parabola. Next, we have 3x squared plus 6x plus 2. X equals negative b over 2a. We get negative 6 over 3, or 2 times 3, which is negative 1, because it's negative 6 over 6. So y equals 3 times negative 1 squared plus 6 times negative 1 plus 2. We square the negative 1, that's going to become a positive 1, times 3. This becomes negative 6 and a 2, so we have negative 1 left over. Vertex, negative 1, negative 1. We draw our x and y axis. From negative 1, negative 1, it does open up. It hits, if all the x's are 2 or 0, we hit it 2. We do a mirror image there, reflection, it's at negative 2, 2. We have our 3 points, and we can draw our parabola. Now keep in mind that coefficient out in front is a 3, so it should be a more narrow graph. And they're pretty close there, but this one is the more narrow of the two, if we look at this, the top ones. Our next one is negative x squared plus 2x minus 5. So negative b over 2a, we get negative 2 over 2 times negative 1. This becomes negative 2 over negative 2, so it's just 1. Y equals a negative 1 squared plus 2 times 1 minus 5. This becomes stays as a positive 1, but it's negative. Negative 1, 2, and 5. So we have negative 4 is our vertex. 1, negative 4. So we're going over 1, down 4. It opens down, and if x is 0, we're left with negative 5 as our y-intercept, so that's 0, negative 5. It can reflect over to be 2, negative 5, and we can draw our parabola. Next, we have x squared plus 6x minus 2. X equals negative b over 2a. Negative 6 over 2 times 1 leaves me with negative 3. Y equals negative 3 squared plus 6 times negative 3 minus 2. We get positive 9. That's negative 18 and negative 2. So y equals negative 11. So our vertex is negative 3, negative 11. See if we can fit it here. So we go left 3 and down 11. So that'd be right here. Negative 3, negative 11. Now we hit at negative 2. So that's 0, negative 2. And it opens up, going through those points. Now if that hits there, our other point is going to be 3 units over to the other side. So that is that, we'll cut into the graph here, or the work, and that's going to be negative 6, negative 2 is our other coordinate. And there's our parabola. Okay, moving down, we're going to go negative b over 2a. We have negative, let's change this one and make it 6. So we're going to go negative 6 over 2 times negative 3. This becomes negative 6 over negative 6, which is 1. So y equals negative 3 times 1 squared plus 6 times 1 minus 8, or negative 3 plus 6 minus 8. Now this is negative 11 together. With a 6, we're left with negative 5. So our coordinate is 1, negative 5. This parabola will be opening down. So we go over 1, down 5. It hits at negative 8, so that's 0, negative 8. Now if that's 1 over, we go 1 to the other side, so that's 2, negative 8. And there's our quadratic. Last one, x equals negative b over 2a. Negative negative 8 over 2 times 1 gives us 8 over 2, which is 4. Y is going to be 4 squared minus 8 times 4 plus 2. We get 16 minus 32 plus 2. Now 16 minus 32 is negative 16. Plus a 2, we get negative 14. So our vertex is at the coordinate 4, negative 14. Now this one's probably not going to fit, so we're just going to approximate on our graph here. So let's say 4, negative 14. Ah, I went the wrong direction. Let's say it's about right here. So we go over about 4, down 14. So if that's at 4, negative 14, it's going to hit at 0, 2. We went over 4 units, so we go another 4, and that's at 8, 2. And there we have our quadratic.